All right, 3.8, graphing absolute value functions. An absolute value function is a function that contains an absolute value expression. All right, that makes sense. The parent function of absolute value is f of x equals absolute value of x. Its graph is a V shape, and it's symmetric on the vertical axis, the y-axis. The vertex, and this is a new vocab word, the vertex is wherever it changes directions. In this case, it's 0, 0. The domain of absolute value functions are always all real numbers. And then for the range, you're actually going to need to look at the graph and see how low does it go. What's the bottom piece of the graph or what's the top of the graph? Now, you can, I'm not going to do it here, but you can, if you were to plug into an XY chart, we could put in the points -2, -1, 0, 1, and 2. Well, you know what, I will. And we're plugging into the parent function, f of x equals absolute value of x. For -2, whenever you plug that in, you get a +2. That's that point there. -1 would give you a +1. 0 would give you 0. 1 would give you 1. And 2 would give you 2. Right? So you could go about this and do a t-chart for every single one of these, and that would be okay. That would not be wrong. But we're going to try to look at them as if we're shifting them, like what we learned with the lines. 29, graph g of x equals absolute value of x minus 3. So I'm going to graph the original, and then I'm going to graph the new piece on here. So the original, we have a point at 0, 0, 1, 1, and 2, 2. Right, that's the parent function, f of x equals absolute value of x. This one, g, tells us to go down 3 units. So I'm going to go down 3. There's my new point. Down 3 for the next one, down 3 for the other. There we are. Now again, you could have made a t-chart and plugged in, and you would have gotten the same exact thing. You would have gotten the same points. All right, let's look at example 30. Now this one we're stretching and shrinking, so I think that we should just go ahead and do t-charts for both of these. We'll do r of x over here and s of x over here. T-chart, we have x, y. We'll put in -2, -1, 0, 1, and 2. Whenever I plug in a -2 inside the not parentheses, what are those called? Absolute value bars. -2 in the absolute value bars makes it go +2, and then times -2 gives me -4. -1 in the absolute value is +1, times -2 is -2, then 0, -2, and -4. Now, before I graph this, we can tell some things about this using our translation rules, our transformation rules. The negative makes it flip over the x-axis. So this is going to be a V shaping down, more like a mountain. And the 2 stretches it, so it makes it like taller. Whenever I go to graph these, -2, -4 is here, -1, -2, 0, 0, 1, -2, and 2, -4. And there we are. Next up. This one, there's no negative out front like on the other one, so this one's going to be nice. It's going to be facing up. The 1/2 means it's going to be a vertical shrink by 1/2. So it's going to make it fatter, right? How this one is kind of narrow, this one's going to be opening wider. It's going to be fatter. There's a 1/2 out front. I don't really like to graph decimals. So what I'm going to do is I'm going to pick numbers that would give me nice numbers whenever I plug them in, right? The 1/2 will give me a nice number for anything that's even, right? Because you could take 4 divided by 2 is 2. So I'm going to pick even numbers. So I'm going to start off with -4, negative 2, 0, 2, and 4. Whenever I plug in negative 4, I get 2. Negative 2 gives me 1, 0, 1, and 2. Whenever I graph these, negative 4, 2, negative 2, 1, 0, 0, 2, 1, and 4, 2. And there we are. All right, very last thing, vertex form. That's on page 170. What is that? 170 in your book. Take a look at that, and you can use that. That just kind of combines all of the transformations, and you can look at that and see that, right? I want to talk really quick. Oh, the vertex of number 29. We changed the vertex here. It's this point. That would be at what? 0, negative 3. That would be the vertex of that. All the other ones, we didn't shift them up, right, left, down, so the vertex stayed at the point 0, 0. Let's also do the domain for 39, or excuse me, that's 29. The domain of the orange one would be all reals. The range, on the other hand, well, you think about, what I normally do is I think about my pencil sitting down here, and it's kind of moving slowly up. And where does it touch? It starts off touching at negative 3. That's less than or equal to y. And you could leave it just like that, or you could put the less than positive infinity. I'm good with either of those. So that would be how you would do the range on number 29. All right, that's all.